So because I am a tremendous idiot, I forgot to farm. Great, and now the game captures. Yeah, I forgot to farm, and I realized that if I don't farm today, I can't finish this dumbass event. So I was like, shit, might as well do it. So we're trying to get 50 uh, SMG kills and then 50 semi kills and then go the fuck to sleep. Almost slept early today. I almost did it. Then I remembered. Fucking buffoon. This team we're fighting is like extremely fast too. Like the people that are on their team are actually like intelligent. Making and I'm not, as you can tell. So it's making things that much harder. Okay. Go ahead and start bumping a podcast. Fuck, why do I keep spawning back here? Alright, Nate Higgins. I saw a pretty cool one. Why our markets rely on the complexity of nature. That's a pretty cool
This is
one.
the crux of the whole problem. Individual parts of nature are more valuable than the biocomplexity of nature. If we can build markets to value that biocomplexity, maybe there's the potential for those markets
What are my guys doing?
to actually propagate complexity over simplicity. Now, critics would say using the same broken economic system to try and fix everything will only cause more harm than good. So the opposing argument is that we just need to distribute wealth more equitably to the local landowners and the stewards of nature, who are the ones that work with nature and who value biodiversity inherently. And these are the people who can transform our future.
Today I'm joined by ecologists.
See, like, what the fuck? Why is that guy so
who studies
fucking
the connections
fast?
between biodiversity.
Oh jeez.
Climate change.
Oh, he's got the fucking premium
Tom
ass
is the
squad. Gosh
founder
dang it! Of
of
course I'm
Crowther
farming
Lab,
and
as well as the chair of
against
the advisory council
nerds.
of the Nation's decade on ecosystem restoration, as well as the founder of Restore, an online platform for global restoration of ecology movement. Crowther's landmark research, published in 2015, transformed our understanding of the world's tree cover, estimating there are around 3 trillion trees yearly. His follow-up paper 4 years later estimated that if viable land could be protected, there would be room for 1 trillion more trees on planet Earth, which could capture up to a third of the excess atmospheric carbon to date. This paper sparked massive public awareness about the importance of trees, catalyzed a global project focused on the restoration of natural forests.
what the fuck?
In 2021, the World Economic Forum named Tom Crowther a young global leader for his
I'm
work
in a
on the
BR5.
protection and restoration of biodiversity. These types of conversations always remain favorites of mine as we get to explore the possibilities of what our biosphere is capable of when given the support
Sorry about that.
and space to fully enact its natural
Oh, there goes my
processes.
rally. Holy shit,
Tom's
I cannot
work
catch a
combines
break,
an
dude.
ecological approach with advanced technology and analytics to propel rapid and effective restoration across the entire planet. Please welcome Tom Crowther. Tom Crowther, welcome to the program.
Thank you so much for having me on, Nate. Looking forward to it.
If the world wasn't kind of falling apart, I would have people like you on all the time, because your work on ecology and ecosystems and forests and biodiversity is what I'm personally most interested in and fascinated by. So let's just start with a big question. Can you explain why biodiversity is so important to life, especially complex life, on planet Earth?
Yeah, well, that's a good setup. I do feel like I'm like the most privileged person on the planet that I get to just study this emergent property called biodiversity. When we talk about biodiversity, we're referring to the infinite network of living things that sustain all of the rest of the living things. Every species depends on other species to survive, and it's only through this emergent property of this infinite web, this network, that allows us to survive. And it's a beautiful thing.
Fuck,
because
I didn't even
many of
see
us, you
them.
know, you might see David Attenborough documentaries about how some animals facilitate one another, or mycorrhizal fungi facilitate plants, or whales have remora fish that get facilitated by them. But we also see
Fuck.
that even antagonistic interactions
Damn it.
also help biodiversity. So you see when a wolf feeds on deer populations, it can increase biodiversity of the plants and transform landscapes. When lynx feed on hares, they improve the biodiversity below. And we find that the deeper and deeper and deeper you look into this magical network, the more intricately dependent everything is on everything else.
And that happened over time and became evolutionarily stable until, you know, the humanity's great acceleration, perhaps. But these things happened over millions of years to become stable.
Yeah, so there's this idea that, ecologists have been trying to understand how stability gets formed in these incredibly complex dynamic systems for centuries. But one idea sort of stands out to me. It's called the stress gradient hypothesis. It's this idea that at the dawn of time, when everything was really harsh and really stressful, life was pretty unlikely. But something magical happened. We still don't know exactly how it emerged, but life emerged on the planet, and the presence of life started this chain reaction, this positive feedback loop, where the existence of life transformed the environment so that other species could emerge, which transformed the environment further so that other species can emerge, which transformed the environment further so that more and more and more species could emerge. And once we got to the great oxidation event, with the oxygen being emitted into the atmosphere, then building a world where thousands of species can emerge. But the deeper and deeper and deeper we got into those facilitating interactions, the more and more and more antagonistic interactions emerge, which means the more things started to feed on each other and compete with each other and fight with each other. And one example that I was most inspired by at the beginning of my career is this idea that even if you put fungi that are going to fight against each other into a petri dish, they will find this emergent property of biodiversity. So we stick two fungi in a petri dish, one will usually kill the other. You stick a third one in, and sometimes that third fungus will kill the winner of the previous interaction. But it might also lose to the loser, and that means you get like a rock, paper, scissors system, right? So one beats the other, that means they all survive, the system doesn't collapse. Now that can be quite rare when you've only got three fungi, but as you add a fourth, and then a fifth, and then a sixth, and a seventh, the chances of finding those rock, paper, scissors, those what we call intransitive loops, increases and increases and increases.
This is crazy,
so
man, how quick they are.
Gives rise to more biodiversity. It stabilizes biodiversity. The essence
like
of
they're about to break my rally.
is in its diversity gives rise to stability, and that is why we've all been able to proliferate on this planet.
So I have a lot of questions, Tom, but I'm going to use this opportunity to just show my fossil from the Great Oxidation Event 2.1 billion years ago in northern Minnesota, was an ancient ocean. These are stromatolites fossilized in iron, one of my prized possessions. Okay, so first of all, briefly define biodiversity for us, and then I have some questions.
Can I just say that was not a setup, that I was just talking about the Great Oxidation Event, and you're sitting next to a fossil of the Great Oxidation Event.
It's sitting under like piles of books and power bar wrappers and other things, and I was like, where is that thing? I haven't seen it in like a year, so thank you for the reminder.
What were the chances I was going to say GOE in that answer? So good.
Define biodiversity, my friend.
The infinite network of life that supports the rest of life. But the challenge is, I will add a caveat. In my opinion, the difficulty with biodiversity is that humans are incredibly good at noticing individual parts of this network and valuing individual parts of this network. So
I ain't gonna get 50.
We see the banana plant and we go, great, that's awesome. But the second we place a value on that part, those banana plants get propagated at the expense of the rest of the forest. We value the carbon, and that's great. Carbon's wonderful, and it's great if ecosystems are storing carbon. we value that part, and then we propagate it at the expense of everything else. And the challenge with biodiversity is not getting stuck into any individual definition of any individual part, and instead recognizing the whole.
So if we have 10 species and then there's an 11th that is added, it's not like the whole thing is 10% better. There's some other math going on, yes?
Exactly. You can't characterize biodiversity by the number of species. Sometimes, for example, you cut down a rainforest, you'll actually get more species of microbes in the soil because you've gone from hundreds of fungal species to thousands of bacterial species in the grassland that will emerge afterwards. So if you were only to calculate biodiversity by the number of species, you'd be vastly misrepresenting the natural state of things. So in my opinion, biodiversity it's more of an emergent property of the complexity of life in its natural state, the complexity that has emerged over millions of years of these incredible evolving ecosystems.
So I am a big fan of David Sloan Wilson and recently deceased E.O. Wilson's paper on multi-level selection, where they studied humans and that in ancestral times, selfish individuals outcompeted cooperative individuals within a group, but cooperative groups outcompeted non-cooperative groups, and so that humans are hardwired both for cooperation and competition depending on circumstances. So in your little story about life begetting life and biodiversity going towards more biodiversity, what role does cooperation hold in the natural kingdom historically?
That is a really good point. That's a really good question because there's a lot of debate over this topic. You know, the selfish gene idea, or the relative importance of positive interactions versus negative interactions within nature. And I actually like to think about it through the lens of feedback loops, right? So a positive feedback loop is one where
I'm so mad.
An inciting process kicks off a reaction that reinforces that process and makes it happen more and more and more. So those could be examples like facilitation, like, you know, the presence of the coral reef attracts fish who produce feces that then provide nutrients that allow the coral reef to grow more, so the coral reef thrives because of that positive.
Is that called symbiosis?
That's not quite a symbiosis. The symbiosis is when there's a mutualism, is when there's an individual species dependent on another. But the symbiosis I think you're referring to, a mutualism is just when the presence of one benefits the presence of the other, whether it's trying to or not. But yeah, these are all symbioses ultimately. These are all ways in which they positively interact to shape each other's presence, and the more of those symbioses you have, the more species you'll get. But at the same time, there are these negative interactions, and sometimes those negative interactions get a bad name, like the cheaters or the predators or the competitors or the fighters. And what's incredible that we learn through the process of biodiversity is that those things, those negative interactions, as you might, if we were to anthropomorphize them, well, it's not anthropomorphizing, if we were to just characterize them as negative, what we learn is that actually they are exactly as important for the stabilization of biodiversity. Because
what the hell's going on?
If you don't have those negative interactions, then one species will always emerge and demolish the entire system. So if you can imagine, that classic example is, you might have heard of Lotka volterra, one of the earliest they were very early quantitative ecologists, and they saw hare and lynx populations undulate over time. As the hare populations increase, then the lynx populations would increase, which would make the hare populations fall.
I think we got
so the
that
lynx
at
populations fall, so the hares that go up and they're just undulating together. And that's because of a negative feedback loop where antagonism or predation is maintaining the system. So it's really this magical balance between the positive feedback loops and the negative feedback loops that forms this immensely magical system.
Let me ask a difficult but simple question. Why should humanity in 2025 care about biodiversity? And it seems to me that it's generally assumed that biodiversity is a good thing, and that people care about it, and they're looking at
that dude is so
biodiverse
fucking
hotspots.
annoying. Oh my god!
And I think, my sense is that we want 11 species rather than 10, and we don't really understand the depth and the importance of the things that you were saying, and why are not in all the climate and planetary boundary discussions, why isn't biodiversity and this intricate interlinked complexity of symbiosis and mutualism and all the things like front and center? Big question.
It's a big question. It's also the question that I go to sleep thinking about every single night. So the first point is a very easy one. Why do we need to save biodiversity? Well, because everything you've ever eaten, drunk, breathed, worn, sat on, consumed, anything has come from biodiversity. It has come from nature, and it would never have existed without it. Some people say 40%, 50% of the economy is dependent on biodiversity. I say that's absolute nonsense. Clearly, 100% of the economy is dependent on biodiversity. We wouldn't be here if it wasn't for biodiversity. So that part of the question's easy.
What the hell is the underground
Why it's
part?
not integrated into the rest of our societal thinking and our,
That's interesting. I didn't even know about this.
Sustainable development goals and the planetary boundaries concept and all these things. This is a bigger question. I think society is only just waking up to this complexity. It's like society was woken up to the climate conversation, and they suddenly realized climate change is a devastating threat to all of humanity, and so everyone got behind it and this movement began. Granted, still not big enough in my opinion, but there's momentum for this movement. When you then say, well, now actually there's an even bigger threat underpinning it, which is the loss of biodiversity, people go, oh my God, okay, what is biodiversity? And you go, oh, it's this complex system, and they go, oh, it's a bit too much. And so for me, it's this. Biodiversity has the power to inspire people, but the complexity of the topic might have gone over people's heads. And I think what's critical right now is that we highlight that this is an even bigger wave. It's an even bigger tidal wave coming behind climate change. It's an even more fundamental threat to the existence of our planet and to the existence of our species. And we need to be exactly as urgent in our drive to save biodiversity on this planet, because otherwise, even if it wasn't necessary for our survival, would we even want to live on a planet where biodiversity didn't exist?
So I would like you to give some concrete examples. Here's one that I can remember, and you can either explain this or offer your own. When I taught Reality 101 at the University of Minnesota, I used this 7 or 8 minute video where there was a relationship between plants and ants, and there were like 50 species of ants, and 50 species of plants and flowers. And when you removed a few species of ants, there was no impact on the flowers. And when you moved a few more
I wouldn't have
species,
even been
there
in
was
that
just a
battle if I
slight
had
impact.
been
And then that
smarter.
stayed kind of constant for a while. But then when you removed like
Swap my
half of
plane
the
to
species
a
of
plane
ants, there
that
was a
is not
massive decline in
that plane.
the presence of these plants, or I don't remember the details. So can you give some specific example of the actual decline in biodiversity past a certain point has a tipping point or a domino effect where a monoculture or a viable living things don't have the biodiversity to function as a whole, a healthy ecosystem?
That's and again, a perfect analogy, because biodiversity, you can almost imagine it as a web, just like, or a net. Imagine a fishing net. You want to catch some fish, you need a functioning fishing net.
Sweet.
But as you start snipping individual rungs on the net, it's still okay. There's redundancy built into it, right? If you have enough species, there's redundancy. You can lose a few links, and the system doesn't collapse. Once you've snipped the net too many times, it starts to have some really big holes, but maybe it's still functioning as a net because some of the central cords are still there. Eventually, you're going to lose a part of that net. You're going to snip one of those cords, and the system falls apart entirely. It's no longer even recognizable as a net. It's just a thing with a hole or a giant, whatever it is, it's dangling rope. And it's this tipping point between being a net and being just a collapsed system that we're actually experiencing a lot around the world right now. We're seeing systems that were maintained by positive feedback loops, like the coral reef and the fish. As long as the coral reefs are there and the fish are there, then the both will be sustained. But then you'll see overfishing or coral bleaching. One part of the system will be gone, which means the other part disappears, and then the entire thing collapses. And you see examples of this in ecosystems all across the planet. One of my good colleagues, Manuel Verdugo, he studies ecosystem resilience, and he thinks 51% of the ecosystems across the planet, or at least more than 50% of the ecosystems across the planet, are currently tipping into those unstable states, or they're tipping out of their stable states. And it's usually because you've broken one of these links. You've broken one too many of these links. Like an easy example would be forests are currently turning into grasslands in many ecosystems around the world. What happens is, we remove some trees, the forest is still okay. It's still producing enough moisture in the air to sustain forests. It's still blocking out enough light so that the understory is in its natural state,
so
and
we need
fungi are able to
30
propagate.
and 8.
Once we've lost enough trees, suddenly the system starts to tip quite wildly in another direction.
2 in the
because
morning?
the
It's
light
2:15.
breaks through,
Gosh
and
dang
that means
it.
grass can emerge.
Oh,
and
I wish I
grass
remembered this earlier.
They have evapotranspiration at a much faster rate than the trees, so moisture gets lost, which means the soil dries out more, which means fungi disappear, which means bacteria arrive instead, which then promote grass, which then dry out the soil even more so that the trees can't survive, and gradually you've built this new feedback loop that quickly tips the ecosystem into an entirely new system altogether. And we're seeing that all over the planet. Forests are tipping into grasslands, wetlands are tipping into drylands. In the northern hemisphere, we see shrublands tipping into forests. It's quite chaos when we see these systems, when we see biodiversity within these systems just being lost to that extent that the systems will tip.
So when we think of life or a tree or an ecosystem, that is a narrow boundary definition of something that has complexity and biodiversity, which would be a wide
feel
boundary
like I'm about to be Germany.
definition. And our economic system
these guys again.
typically
All
uses narrow boundary definitions. So, for instance, I know in Spain, they're doing a lot of monocultures
Oh, it's this fucking
with
map.
eucalyptus and other trees. So from an economic narrow boundary vantage point, oh, look, there's more trees
Honestly,
in Spain. That's a good thing.
I kind of
But
don't
from
want
a
to play
wide
this
boundary
map.
perspective, we've lost the biodiversity and the complexity of the ecosystem. Can you speak to that?
Yeah, you nailed it. Those trees are not an ecosystem. That monoculture of eucalyptus plantation is nothing to do with a functioning, thriving ecosystem that can be sustained in the long term.
Oh, I've joined
if you
any
were to
army
see it through
off.
the lens
I'm
of a
fucking
farm,
idiot.
that's fine. We need farms, we need agriculture, and I'm a massive fan of agriculture, and we certainly need that. But that is what that plantation of eucalyptus is. It's a paper farm, and if we want it to be recognized as a viable ecosystem that will trap carbon and store biodiversity in the long term, then it cannot be a monoculture, because the only thing that maintains the stability of the system is the interactions with other species. One group of organisms alone in a monoculture cannot be sustained, because fundamental rule of ecology is every species depends on others to survive.
So moving into your most prolific academic background, which is centered on trees and forest, why are trees and forests and those sorts of ecosystems so important to biodiversity and the planet?
Yeah, so I would just throw out the caveat that actually we work on grasslands and peatlands just as much as we do on forests, but it is true that the forest topic has received a huge amount of attention in recent years, and I think that is due to the momentum that's growing around climate change. Forests store hundreds of billions of tons of carbon, and when they're healthy and they're old and they're diverse, they can store that carbon for millions of years. They are an incredible trap of carbon. That's not to say that grasslands aren't storing loads of carbon and peatlands aren't too, but these systems are really gaining momentum because they are a system that we have depleted so much.
How can they store it for millions of years? There's no trees that live millions of years, so they die, and then what?
Yeah, correct. Individual trees come and go all the time, but the forest system is what sustains. The forest ecosystem is what stores carbon for millions of years.
So it's some are dying and some are growing and taking in more carbon as they grow, and the net is a storage of carbon.
Exactly. In the same way that your cells are dying and then regrowing and your system is maintained, the forest is the same emergent property of this collective of organisms.
So your most famous study to date was a sort of global tree census, which reported that we currently have around 3 trillion trees on Earth. and room for another trillion. Tell me about that research. How did you go about putting this data together, and what were the big takeaways from that work?
Yeah, so I would say at the time, our understanding of the understanding of our planet came from a very heavy focus on the physics and chemistry of our planet, and we didn't have many global models about aspects of nature because it's really hard to measure this complex system in its wholeness. So we were kind of inspired to do this by an NGO that wanted to do large-scale ecosystem restoration, but they wanted to know how many trees should they restore in order to have a meaningful contribution. If you don't know how many there are to start with, it's hard to put things in context. So they asked us a simple question: how many trees are on the planet? And we tackled this by essentially reaching out to thousands and thousands of ecologists, coordinated by hundreds of research groups, all of whom have been studying their forests in different ecosystems around the world, because all of them have data on the density, the structure, the height, the diversity of those plants. They could share that data with us, and we could start to build this global picture. The more and more data we had, the more we started to understand the patterns of tree density around the world. And then you link that up with satellite observations, and you've got all you need to make a global model about the structure of global forests. And yeah, we were pretty astonished to discover that there's over 3 trillion trees on our planet. But it was also quite a sobering discovery, because we realized that there would naturally be about double that number. There would naturally be almost 6 trillion trees. So we've halved the scale of this global forest system, and in fact, we continue to lose about 10 billion trees every year.
Over what time frame did we go from almost 6 trillion down to 3 trillion trees?
10,000 years. Start of the agricultural revolution.
And just a nerdy side question. I know that there are around 6,000 species of mammals. Do you know how many species of trees there are?
In fact, funnily enough, using exactly that same data set, we published a paper just 2 years ago showing that there's about 70 or 80,000 tree species.
Yeah, cool. So, what would be the benefit of having an additional trillion trees on Earth, and is that project still underway?
So, yeah, funnily enough, this was actually the next study that followed on. Once we'd showed that there's 3 trillion trees on the planet, we wanted to figure out, all right, is there any room for recovering more ecosystems? And we realized, obviously, of the area that's been lost, let's say 3 trillion trees have been lost, of that area, we still extensively use about 2/3 of it for cities and agricultural land. And so that's obviously out of bounds. These are places where people are managing their ecosystems. Obviously, we'd love for them to manage them more regeneratively and integrate biodiversity. But these are places where you don't want to be, there could be conflicts between people and nature. But we also realized that there's about 1/3 of this land which is not under heavy human footprint, where if it were the economically viable option for people, that there's the potential for these trees to recover. So about 1/3 of that land could potentially recover. And what was pretty staggering to us at the time is that we estimated that if those ecosystems were able to regenerate, if we could sort of like put up fences, let nature return, that it would capture over 200 gigatons of carbon. So that's about 1/3 of the carbon that we need for our global carbon drawdown goals in the fight against climate change. When that information came out, it just went viral.
Well, not to mention the carbon benefits, but also if done in the right way, the biodiversity benefits potentially, right?
Oh, absolutely. From my perspective, the entire goal of this is to revitalize as much biodiversity as we can on the planet. And let's face it, the people who depend on that biodiversity. There are millions of communities around the world, billions of people around the world who are fundamentally dependent on local biodiversity for their own well-being. And it's those people for whom biodiversity recovery is most vital. So yeah, this is a human story and a biodiversity story.
So my understanding is that you received quite a bit of pushback and criticism from the ecological community on that paper for being overly simplistic. Can you expand on the nuance, the drawbacks within your idea to restore 1 trillion trees?
Yeah, it is true. We got some heavy pushback, and it was a pretty hard time.
When was this?
This was in 2019.
Okay.
2019, we published this paper in the journal Science. 1/3 of the forested land can be restored. That's room for 1 trillion new trees. 1/3 of our carbon drawdown goals. Unbelievable. Front page news on in every newspaper. But it was pretty devastating as well, because yes, people said it was oversimplified. And in all honesty, I want to be crystal clear. Yes, any global model you have ever seen is an oversimplification. There is no way you're capturing the full nuance and detail. So what these global models like this
there we go.
is you'll have lots of places where there's an underestimate, lots of places where there's an overestimate, and you hope through the basic fundamentals of statistics that you'll overestimate as much as you underestimate, and as a result, the total global amount gets more and more robust with what data you have, and we had huge amounts of data. So that's why this paper sort of got into science, that's why it got all this attention. But the real problem, the real challenge at the heart of 2019, which was a pretty defining moment in my career, was that in our communication about this study, that's where we were overly simplistic. We said we can restore a trillion trees and have massive contributions to climate change. The problem is, if you say that to the media or to the general public, understandably, they might assume that means planting rows of trees, not allowing nature to recover. And that subtle difference led to headlines saying planting a trillion trees will save the world, which is fundamentally incorrect. And it's dangerous for the climate change conversation, because people can use it as greenwashing. They can, plant a few trees and ignore the real challenges of cutting emissions and, limiting their greenhouse gas emissions. But it's also devastating to the biodiversity movement, because people are cutting down rainforests to plant rows of pine trees, which is the exact opposite of what we would ever want to have. Our study was about the real potential of complex biodiverse nature, nothing to do with brutal, vast monocultures of carpet simplicity that destroy life on Earth. So it had its pros and cons.
I have a ton of questions on that. So presumably planting trees in an area where there are no trees would be a benefit, especially if it was a lot of different kinds of trees and not just eucalyptus. But planting trees where you had to cut down existing things to plant new ones, obviously that wouldn't contribute to a larger goal. So is the just the planting, is that a negative, or it's the nuance behind the concept of planting?
I'm so glad you asked that, because since then I often tell this story and people go, "Oh, Crowther says planting trees is bad too." That is definitely not the case. I am neither for or against planting of trees. What I'm for is revitalizing nature wherever we can, as long as it's for the well-being of the people who depend on it. So in some cases, if you're in a place where forests naturally existed but they're struggling to recover, maybe the soil is degraded or the microbes are not there, then planting can actually be a really active, positive action, especially if you're doing it in a diverse way. In other systems, you might just want to remove the sheep and the trees will recover naturally. And one really big question we have in ecology is which ecosystems will recover on their own, which ecosystems do you need to be active? So there is no real answer about whether planting is good or bad. The only question is, where can biodiversity be returned and how should we achieve it?
Here's a dumb question. In the NGO and government and various institutional orgs around the world, how many of them have the ability to even model some of this ecological and biodiversity complexity that you've been describing? Or is it just a guess?
I would say that advances in academia over the last 5 to 10 years in global ecological modeling have been absolutely transformative, because we now for the first time have the ability to access the knowledge of people all across the planet and build these incredible models. That is slowly starting to seep into the industry or the not-for-profit or the governmental world, and I think it is slowly making its way. I don't think it's there yet, but gradually this richness of knowledge is starting to seep into those systems. But until now, they have all been devastatingly depauperate in strong biodiversity information.
So it was my understanding that actually President Trump in his first term kind of took the 1 trillion trees as a rallying cry among other people in the world. So 5 or 6 years on, how have governments, NGOs, and businesses been responding to this call to grow our tree census from 3 trillion to 4 trillion?
The reaction's been unbelievable. I would honestly say it's been the most astonishing thing. So 5 years ago, when the first headlines came out, it is true, everyone was talking about how many trees can we plant, how many trees can we get in the ground, and that was oversimplified. Again, tree planting can be great if it's empowering a local community, but in reality, mass plantations are not what we need. And so the conversation kind of blurred. There was a lot of people doing wonderful things, but a lot of people doing greenwashing. However, the pressure, what's really interesting is both the positive and the negative feedback that idea got pushed the conversation in a really, really positive direction. So grassland scientists correctly said you should not be planting trees over native grasslands. Biodiversity scientists said you should not be doing monocultures. Climate change experts said you should not be using this as an excuse to cut emissions. And over the last 5 years, the whole conversation, the whole narrative has changed. First, nature is now a front and center part of the climate negotiations. It's in the conversation. And second, they're not just talking about trees and planting trees. They're talking about how do we find and empower the indigenous communities who are the people protecting trees? How do we empower the local communities and farmers who are the ones that are revitalizing biodiversity for their own well-being? And that is a much richer and more nuanced way of restoring global biodiversity. And honestly, since the launch of the United Nations Decade on Ecosystem Restoration, that movement has been flying.
Is there a clearinghouse that is able to rectify and collate the climate and the ecology and the soil and the trees within these organizations? Or is it so many reductionist experts, even though they're system scientists, talking about their thing?
Yeah, the reductionist thing is still pretty devastating. Unfortunately, some people are counting numbers of trees, others count area of land. There's always a reductionist version of this assessment. But one thing I am quite excited about is, we're all a big fan of the planetary boundaries concept, which has nailed the physics and chemistry of the planet. And they are now increasingly integrating biodiversity information into that annual update census. There's a massive network of ecologists collaborating on a project called SEED, which is measuring the sort of complexity of biodiversity across the globe and seeing how that's being depleted or recovering in different regions, and that's getting integrated into that planetary boundaries assessment. So I do think there's going to be big change in the coming years.
So I do remember reading something you wrote using the term biocomplexity. What does that mean?
Yeah, I think biocomplexity is the term that I use to get people past the confusion around biodiversity. In essence, when people think about biodiversity, they think about the number of species, or they think about the number of trees, and both of those are oversimplifications that will cause more harm than good. The point about nature, the point about biodiversity, is that its strength and its stability is in its complexity, its biological complexity across genetic levels, across species levels, and across ecosystem levels. You need genetic diversity within species, you need a diversity of species, and you need complex structured ecosystems that can support all of this. And so biocomplexity was a term that I started using quite recently to characterize that complexity of the system across those three levels. And if we have a healthy level of biocomplexity, we can then start to say this is an ecosystem that's getting back to its natural state.
In the one corner, we have biocomplexity, and in the other corner, we have dollars and euros and yen. It does seem to be like totally opposite goals for the long-term health of our planet and the short-term viability or perceived viability of our next quarterly economic system. But I agree with you. Biocomplexity is ultimately where it's all at in the intermediate and long term, for sure.
This is the crux of the whole problem.
Damn, everybody
Individual
died.
parts of nature are more valuable than the biocomplexity of nature. So if that's the case, then we're always going to propagate those parts.
They are right fucking there, dude. Our team is
behind the
sucking.
creation of this
We are not doing
seed
shit.
biocomplexity index that I told you about. If we can have a measurement of that biological complexity, and then if we can build markets to value that biocomplexity, maybe there's the potential for those markets to actually propagate complexity over simplicity. This is the sort of the dream of the movement. Now, critics would say, and in all honesty, I probably agree with them in many ways, using the same broken economic system to try and fix everything.
Why do we
only
just throw
cause
at
more
the
harm
end?
than
That's
good.
tragic.
Because if it drives inequitable distribution of
talk
wealth,
about tragic.
it's still only going to lead to billions of people being trapped
I
in
bet
an
I didn't
economy
get
that
enough,
doesn't allow, where they're trapped in with no non-extractive alternatives. So the opposing argument is that we just need to distribute wealth more equitably to the local landowners and the stewards of nature, who are the ones that work.
Bada bing, bada boom. We're going to fucking bed. Slay. It's a shame that I can't pad out the challenge with these, because now I have to do literally everything else perfectly over the next... How many days is that? 3 days? May 13th to May 19th. Wait, that's 6 days. Oh. Yeah, I'm stupid. Okay, yeah, 6 days isn't bad, I guess.